Testing. Howdy. My name is Victor Johnson, and I'm a meteorology major at Texas A&M University. Today I'll be giving a presentation on windstorms. In meteorology, windstorms are not as discussed as many other weather events like thunderstorm winds, for example, typically because they're less common or reported or less paid attention to. But in this presentation, I'll first discuss the formal definition for a windstorm, and then we'll discuss how these winds form and how to properly forecast them when looking for certain winds on a particular day. We'll also look at the different types of windstorms explored, and then we'll also look at some record events in history lastly. And so the formal definition for a windstorm is having sustained winds of at least 34 miles per hour, which are strong enough to cause light damage to trees and branches. And so mountain windstorms are typically common in high elevation areas like mountains and highlands. And they typically happen because of significant pressure changes over a slope. And so with bigger pressure differences, you're able to get stronger winds because of those great fluctuations. But often windstorms are notable for being exceptionally strong. As often a typical downslope windstorm can bring winds of over 60 miles per hour, which is exceptionally strong. So typically, airflow first flows upward under a strong pressure gradient, which refers to how much the pressure changes over a distance. And so, with a great pressure change over an area, that you get a strong pressure gradient and therefore strong winds. And as this air moves up over a peak, it produces lead waves, which are vertical oscillations due to this kind of lifting. And so in those waves, air tends to bounce around and maintains this motion as it cannot move downward or upward really quickly. Then finally, what goes up must go down, and so once it reaches the peak, air accelerates downward. Now, as air moves downward, it warms dry adiabatically, and so upon descending, the temperature also goes up. Now, typically, as air moves along, it undergoes a type of compression from the hydraulic jump, which causes the winds to stay strong even as it reaches the peak. So in this way, it interacts with those pressure changes to keep along the strong winds that you typically see at mountains. And so how strong winds are upon descending depend on several factors. One is gravity, which is actually the main factor in driving those winds, as it acts to pull the wind downward upon descending. Also, upstream wind speed, and so the stronger the winds you have to begin with, the stronger they will be as they accelerate downward. Another factor is air stability. So typically, you like to have a more stable profile where temperatures don't change as much as you go upward to bring more acceleration to the wind as it moves downward. And if you're looking for strong winds, you typically don't want to have a jet stream, only because a jet stream is an area of locally strong winds aloft. It actually ends up disrupting the wave pattern and spreads it apart. So the air cannot maintain that wavy pattern to keep that stable environment for wind to descend. So here's a diagram of wind moving along. a mountain and then reaching the other side. And so first, as air moves up a mountain, it cools down until it reaches saturation, and then once it's saturated, it releases latent heat. So typically at the top of a mountain, you'll see clouds appear, and this is because of that latent heat release. And typically at the top of a mountain, because of those leeway patterns, you tend to get turbulence where air rotates and moves along in quite a changeable pattern as moisture and heat gets transferred out of those winds into energy. And as those winds approach the other side, they flow downward and gain temperature and strength, and so you end up with really warm, dry winds, and also the eastward or downward side of the mountains is known for being cloud free because of this kind of warming that dries out the air for cloud formation. So going back to the clouds you see on mountains, so the flat cloud tops that you see on mountains are typically called the lenticular clouds, and so here are certain examples of those types of clouds that you would see near the peak of a mountain. And so as air rises, it cools and condenses and releases that latent heat. And so these types of clouds are mainly caused by those lee waves formed from the gravity waves that interact with that kind of sloped boundary to produce this type of peculiar shaped cloud that you would see. So when it comes to forecasting for a certain windstorm, you'll typically want to look for several features. So one thing you want to check for pressure. So an ideal environment is one where you have a surface high pressure upstream of a mountain and a surface low pressure downstream of a mountain to help create that strong pressure gradient. So for example, on this map, there is, if you look at 1027 millibars and 1005 millibars, there's a big difference between those two levels. And so the bigger the difference is, the greater that strong pressure gradient you can have to help to bring you those strong winds. Next, you also want to see if you have a stable layer near the mountain peak, but preferably you don't want it on the least side of the mountain to prevent that wind from moving downward or gaining strength upon descending. Also, of course you like to have a mountain boundary, and so you cannot see it on the map, but one example would be the Rocky Mountains located on the eastern side of Montana and Wyoming, stretching down into Colorado, and so to preferably a mountain with a gentle slope on the windward side, and then a steep slope on the leeward side. It's better able to support those strong winds, as the steeper it is going down, the greater the acceleration is. And also cold air or sinking motion, and so cold air is typically dense, and dense air often sinks, and so as air is moving downward, if there is air that is moving downward, this in this way it can help perpetuate or even encourage that further downward motion as air is moving along to reach those lower elevations. So now we like to look at the different types of windstorms. And so there are three different types, along with a special case on the dust storms, which we'll look at the end. But we'll first take a look at the Chinook winds. And so Chinooks tend to come from the native word for warm wind, which are the foehn winds, and typically these winds are called warm because of how much they warm up as they descend on the other side. And so Chinooks are pretty common across mountain ranges, like, for example, the Rockies, the Cascades, and the Alps, to name a few. Often the best environment for Chinooks occurs in the late autumn to early spring, where temperatures cool down and there is a broader range of temperatures for that temperature gradient and chances of precipitation to help create those strong winds. And also, these winds are known for reaching significant speeds. Typically, Chinook winds can get close or even exceed hurricane force winds upon descending, depending on how strong they are. Chinooks have also been given the name snow eaters because as they descend, they can warm up pretty drastically. And so, for example, here, for a mountain that's 3 kilometers high, the temperatures can at the top shift from -12 down to 18 degrees Celsius. And so, in these kind of conditions, if there's snow at the base of the mountain, it is probably likely that the Chinooks can help melt it in an instant. And so these kinds of winds tend to occur with several weather features. So one is a stable layer on the west side of the mountain, and so you also like to of course have that strong pressure gradient in place to help create those strong winds to bring up winds along that mountain boundary. And also having strong westerlies at mid levels is a significant factor, as westerlies can in this way can help perpetuate that wavy pattern as they move up and over a boundary to help keep the wind in motion as it falls and gains strength. Another type of windstorm is the Santa Ana winds, and so these are native to the Southern California mountain range, and so in this region the air is typically dry and stable, and you tend to have winds moving downward from high pressure systems that move up and then warm down and gain speed as they descend the steep mountain terrain in this area. And just like Chinook winds, these winds are also capable of warming up drastically, often 20 degrees or so, depending on how high the mountain is. And so for an average basis, this region typically sees about 20 strong wind events, mainly from September through April, where the environment is more conducive to help support stronger winds. And typically, with a high pressure system, you have strong northerly winds that are already dry, and so as they move down they warm up and descend towards the eastern side at high speeds. Now, but these winds can also be problematic for the western side because the state of California is typically known for its dry wildfire season, and so with winds coupled with low humidity, these can be problematic as the winds can help pick up those fire embers and blow them across a new area in an instant, and in this way create new wildfires, which enhances the situation. The next type of windstorm is the katabatic winds, and so this type of windstorm comes from the name Bora, which are called the cold winds, and so these winds are mainly confined to the highlands and polar regions, for example, Alaska, Greenland, and the Antarctic regions. And so because the air is very cold, as it moves down, it's very dense and mainly driven by gravity, which is one of the most significant factors in bringing winds across an area down slope. And of course, if there is snow in the area, these winds can help lead to blizzards once they exceed 35 miles per hour or so. And now we'll look at the special case dust storms. And so these storms are often called haboobs as another term, which typically just refers to a wide wall of moving dust. And so dust storms are mainly localized in desert regions. For example, the desert southwest in the United States, along with the Sahara Desert or the Gobi Desert in northeast China. A typical dust storm can get up to about 2,000 feet high and stretch as long as 5 to 10 miles. They often last for up to an hour, depending on how strong the winds are. But however, these storms can be quite hazardous as for example, they can impact visibility and our breathing hazards. For example, the breathing in dust can be detrimental to your respiratory system, and so you'll want to take precaution in protecting your eyes and your nose when one is around. So what do you need to have a dust storm? Well, for one, you just need a broad area of dry, loose soil, and you also need a source of wind. So typically, what happens is simply the winds become strong enough and to lift up and carry the dust particles over a distance. And as you can see in this picture to the right, this is a picture illustrating a dry thunderstorm occurring over the west. Now, as you'll notice, what's happening, there is precipitation falling from the storm. However, it's evaporating, but this is because of the dry air at the surface, and so because the air is so dry down there, it can't even reach the surface, and so because of this, it just evaporates. Now, and then lastly, I've included some ways in which dust storms carry up dust particles with them. It's not really important, but they're included just for reference. And so to quickly go over these, one method is suspension, and so this mainly refers to smaller fine particles in which winds pick up the dust and just carry it a lot very high. Saltation refers to your medium-sized particles, and so here, as particles bump into each other as they're picked up, they create frictional charges which can help pick up those other medium-sized particles and carry them at those mid-level heights. And then finally, creep. So this one only refers to those larger particles, and so these particles are too large to be carried at higher distances, and so what happens is that they just get dragged near the surface. Now we'll take a quick look at the 1930s Dust Bowl, and so if you lived in the Central Plains during the Great Depression, it was pretty common to see a wall like this coming your way. But what was significant about this weather events like this one depicted here is that during the 1930s, farmers utilized poor farming practices along with the severe drought that happened during this time, and so what eventually the soil just became too loose and gritty to help support crops, and then whenever a windstorm would come through, it would pick up the dust and carry it aloft. And so this map here is a picture of the Dust Bowl area. So it mainly stretches through central Texas into the interior of North Dakota and into the western United States. So maybe we can also ask a question to ourselves: can dust storms only happen in deserts? Well, from the previous slide, you only need a broad area of loose soil and some winds to have a dust storm, and so it really doesn't matter what climate zone you're in. If you have those ingredients, you can have an event like this occur. But typically, the dust storms are more applicable to deserts, because of the type of soil that is able to support them. And now for some safety tips in dust storms. If possible, while driving, you'll want to avoid these dust storms because of the intensity of cleaning required to clean your vehicles after the dust storm has passed. And typically, dust storms can leave about of several inches or even a foot of dust in your wake. But if you do happen to get caught in one, it is best to just slow down and pull over off the road safely. And also, if your vehicle does have the option to recirculate air, you'll want to turn this on so that in this way your vehicle is not it's not bringing in the dusty air from the outside. And if you happen to be that unfortunate person that's outside when a dust storm is coming, you may want to just run and get to an indoor shelter as soon as possible. While you're out there, you also want to make sure that you're covering your eyes and your nose so that you're preventing the dust from getting inside your system. And finally, we'll look at some record windstorm events in history. And so one here would be the Chinooks of January 1982. And so one area for focus in this time was in Boulder, Colorado, where during this month we saw exceptionally strong winds moving downstream of those mountain ranges in the area. And from the events recorded here, the area ended up recording a maximum wind gust of 130 miles per hour. And the winds were so strong and pretty frequent at times that winds would suddenly gust and bring damage to nearly half of the buildings in that region. And overall, damages total close to $20 million. Now we'll quickly take a look at Mount Washington. And so Mount Washington, New Hampshire is known for being the windiest spot in the United States in a climatological basis, and so um dating back to April 12th of 1934, the wind record there was set at, get this, a gust speed of 231 miles per hour. And as you can see right here, this guy is attempting to hold his own as he withstands the strength of those strong katabatic winds flowing down that mountain. And so I'll show you this video of the wind experiment that was taken during that time. And so the the instrument that they used that day is still up for display at the museum. And so if you intend to visit Mount Washington, do try not to get blown over. And lastly, the temperature wind blast to demonstrate how much these winds can really change the temperature. And so the greatest 24 temperature change occurred in Loma, Montana back in 1972. And so strong Chinook winds were moving downslope of steep mountains were ended up contributing to a very sharp temperature change, where temperatures went from minus 54 degrees to 49 degrees above zero. So which constitutes a 103 temperature change. And then lastly, the quickest wind related temperature change. So and this was recorded in Great Falls International Airport back in 1980. And so that day, strong Chinook winds were gusting at high speeds were quickly surfaced near the airport, bringing with them higher temperatures as they warmed up on the descent. And this ended up resulting in a wind-related temperature change from going from minus 32 degrees to positive 15 degrees in 7 minutes. So just a reminder of how strong and these winds can be at changing the air around you. Well, everybody, that is all that I have for you. So, and I hope this presentation has been helpful to you all. if you have any questions, please leave them in the comment section or send one to my email. But thank you all and have a nice day.